Welcome to our deep dive. Today, we aren't just sitting through some boring math lesson. Oh no, we're actually grabbing a master key to unlock the physical world. We're diving into trigonometry, the invisible superpower. Okay, let's jump right in with a bit of a challenge. How do you measure a massive pine tree across a deep river without actually crossing it? You don't have a giant tape measure, and you definitely can't swim across. But imagine standing on the riverbank and forming this invisible ramp with your gaze, pointing straight from where you're standing all the way up to the highest leaves of that tree. Well, that invisible ramp, that's your very first step into harnessing this superpower.
So, what exactly are we doing here? The word trigonometry literally comes from Greek words meaning triangle measurement. Simple enough, right? But here is the truly beautiful truth about nature. If you keep the angles of a right-angled triangle the exact same, the ratio between any two of its sides will always, and I mean absolutely always, remain perfectly constant. It literally doesn't matter if the triangle is the size of a tiny notepad or the size of a literal mountain. Because of these fixed relationships, we can use measurements we can reach to calculate distances we can't, like that towering tree across the river.
Here's our roadmap for today. We'll start with the mathematical superpower, then see how it's hidden in plain sight. After that, we'll break down the fundamental ratios, look at angles of sight, and finally, wrap up with unlocking your future.
Starting with Section 1, the mathematical superpower. You know, this really reframes our whole understanding of math. We usually think of geometry as super rigid, right? Sharp corners, fixed, unchanging shapes. But trigonometry takes that rigid world and turns it into a completely fluid tool of prediction. It's a master key for exploring flat surfaces, 3D space, and, incredibly, the invisible repeating wave patterns of light and sound. By simply looking at a situation through the lens of a triangle, we suddenly gain the ability to map vast oceans, safely navigate the skies, and literally analyze the physical universe itself.
Which brings us to part 2, hidden in plain sight. Now you might be thinking, okay, navigating skies is cool, but what about my day-to-day life? Well, just take a look at this list. Trigonometry is quietly working behind the scenes everywhere. Look at video game design right there in the middle. Developers are constantly using trig to figure out exactly how a character jumps or how light perfectly reflects off a virtual sword as it smoothly rotates on your screen. Or check out satellite imaging and GPS down there. Have you ever wondered how your phone knows exactly where you are? It's calculating your location on Earth by measuring the angles and travel times of signals bouncing back and forth between your phone and multiple satellites. So from builders calculating the slope of a roof to forensic scientists reconstructing the angles of a car crash, triangles are doing all the heavy lifting.
Moving right along to Section 3, the fundamental ratios.
Okay, let's take a look at this table. And hey, don't let the terms intimidate you. In a right-angled triangle, sine, cosine, and tangent are just ratios. That's literally all they are. They simply compare the lengths of specific sides, the opposite side, the adjacent side, and the hypotenuse, relative to an acute angle. Think of them as fixed rules that just say, hey, if the angle is x, the ratio of these two specific sides is always going to be y. Let's actually make this tangible.
This park slide analogy brilliantly illustrates the concept. I want you to imagine sliding down a slide at your local park. That ladder going straight up, that's your opposite side. The flat ground stretching from the bottom of the ladder over to the end of the slide, that is your adjacent side. And the actual slippery ramp you physically slide down, that's the hypotenuse. So if you were to measure the steepness angle of that slide, the sine of that angle is literally just the ratio of the ladder's vertical height compared to the slide's actual length. Boom. Suddenly it's not abstract math anymore, it's just playground physics. Now let's build on this idea a bit with reciprocal ratios. Cosecant, secant, and cotangent. Honestly, these are just the multiplicative inverses of our first 3 ratios. Think about an art class where you are adjusting a wooden drawing easel. As you change the angle of the drawing board relative to the flat table, the ratio of the board's length to its horizontal shadow is the secant. Artists and easel designers actually rely on these exact reciprocal relationships to make absolutely sure the structural supports are solid, so the board doesn't just collapse the second you press down to draw. And take a look at this, the Pythagorean identity. Sine squared plus cosine squared equals 1. This is an equation that holds true for absolutely every value. Picture a grandfather clock's swinging pendulum. As it swings back and forth, its position changes horizontally, which relates to cosine, and vertically, which relates to sine. No matter where that pendulum bob is during its entire swing, the sum of the squares of those horizontal and vertical fractional distances will always equal exactly 1.
Why? Because that 1 represents the constant, unchanging physical length of the pendulum arm itself. It is just a beautiful piece of physical reality perfectly captured in an equation.
All right, section 4, angles of sight.
The absolutely crucial point here is establishing our vantage point in three-dimensional space using a horizontal baseline. Let's contrast these two concepts to make it super clear. First up, the angle of elevation. Imagine you're standing in a school courtyard looking straight ahead. That invisible, perfectly straight line, that's your horizontal baseline. Now, you watch a colorful kite flying high up in the sky. When you tilt your head up to spot the kite, the angle your eyes rotate upward is the angle of elevation. Knowing that angle, plus how far away you are from the person holding the string, lets you calculate the kite's exact height. Pretty cool, right? Conversely, the angle of depression is when you're looking down. Imagine you're standing on a high-rise balcony looking straight out at the horizon. There's your baseline again. When you lower your gaze to look at a delivery van parked on the street below, your line of vision sweeps downward, creating that angle of depression.
And finally, section 5, unlocking your future.
You see, trigonometry isn't just some academic exercise to torture you in high school. It's literally the language of spatial design. Just look at these fields: civil engineering, video game physics engines, medical imaging like analyzing MRI waves, architectural drafting, and aerospace engineering. Mastering these trig principles is the essential step for converting abstract spatial ideas into concrete, functional realities. If you want to design a stable bridge spanning a massive valley or analyze brainwaves to save a life, these triangles are the foundational tools you're going to rely on. But to get to those prestigious careers, you gotta pass the gatekeepers. This knowledge is absolutely critical for highly competitive exams like the IIT JEE, NEET, BITSAT, IISER, and NEST. In engineering exams, it's not just tested through complex, standalone equations. Trigonometry is actually the structural backbone for calculus, coordinate geometry, and vectors. And for medical or scientific research exams, trigonometric modeling is completely vital for understanding physical chemistry wave equations, biological cycles, optics, sound waves, and alternating currents. Building a deep, intuitive grasp of this stuff today is exactly what lays the groundwork for high performance in these competitive fields tomorrow. Which leaves us with this final thought. Now that you know the secret of this master key, what invisible triangles will you use to design our future? The next time you look at a towering building, a plane flying overhead, or honestly even just the shadows casting off your desk, try to see the invisible lines connecting them all. I promise you, it'll completely change the way you see the world. Thank you for diving into this with me. Keep looking up, keep building those invisible ramps, and I'll see you next time.